Hey everyone, how are you today? I hope you're doing well. My name is Mark Middlesworth and I'm with ErgoPlus. And in this very brief video, I want to just introduce the NIOSH lifting equation to you if you're not familiar with it. Here's the very basics of it. The NIOSH lifting equation was developed many years ago, last revised in 1991, but it's a validated tool that is just an excellent tool that is designed to quantify risk of lifting and lowering tasks in the workplace. The primary output of the equation is a recommended weight limit based on the task variables involved for that lifting or lowering task. So RWL stands for recommended weight limit. The load constant for the NIOSH lifting equation is 51 pounds, and then there are 6 multipliers that are used to reduce from that load constant of 51 pounds, again based on the risk associated with horizontal reach, vertical location of the load, and that kind of thing. So the multipliers, the H multiplier is for the horizontal location of the object relative to the body. So from the midline of the body, you measure between the inside ankle bones to the load center, and that will give you the horizontal location of the object relative to the body. The V multiplier is the vertical location of the object relative to the floor. So we'd measure from the floor to the coupling on the object to determine the vertical location. The D multiplier is the distance that the object moves vertically during the lift from origin to the destination. The A multiplier is for the asymmetrical angle or the twisting component, if there is one associated with the task. So you'd want to assess that, determine the degree of asymmetry required by the job and the ergonomic design of that workplace, and determine what the multiplier would be. The F multiplier is for frequency, and there's also a duration component of the frequency multiplier, and the last multiplier is for coupling or the quality of the worker's grasp or grip on the object. So that is the revised NIOSH lifting equation. As I said, the primary output is the recommended weight limit, and that answers the question, is this weight, is the actual load being lifted too heavy for the task based on the task variables involved and measured. The other output, which is very helpful in prioritizing our effort in terms of ergonomic improvement, is the NIOSH lifting index, or the risk index, the degree of risk associated with the task. The lifting or risk index is calculated by taking the actual load weight, the actual weight being lifted or lowered, and dividing that by the recommended weight limit after the calculations are made. So the lifting index answers the question, how significant is the risk? If the recommended weight limit is 25 pounds based on task variables, and the actual load being lifted is 50 pounds, then the lifting or risk index is going to be 2.0, right? 50 is 2 times 25. So that's how that's calculated. Anything above 1.0 indicates that the actual load being lifted exceeds the recommended weight limit, and we would consider that, or NIOSH would consider that, a high risk. So the goal is to design the job and task variables so that we get a lifting index result that's less than equal to or less than 1.0. We have developed a web-based NIOSH lifting equation calculator for single tasks. And so this single task calculator will allow you to input 12 different inputs based on measurements that you take and the objective data that you collect. We also have step-by-step guides that outlines detail by detail how horizontal distance is measured, for example, exactly how you go about doing that. So I'm not going to get in that deep into the weeds in this short little introductory presentation today, but that is available, and we would encourage you to take a look at that. We're just going to make the inputs in the calculator for horizontal location at the origin and destination. I guess the first thing you look at is whether or not significant control of the object is required at the destination. Some lowering tasks or lifting tasks don't require significant control at the destination, and so you don't have to make that many inputs if that's not the case. But in this case, significant control, let's say it is required for this particular task. We have to be careful about the way we set it down. We can't just throw it down. We would collect the data for horizontal location, vertical location, angle of asymmetry at both the origin and destination. We would want to know what the quality of the coupling is and select either good, fair, or poor. We would want to know what the frequency and duration is, and we would also need to collect the average load for that task and the maximum load for that task. Once that information is gathered, then we would push calculate, and this is the result of the calculation. We get a recommended weight limit at both the origin and destination. We get a frequency-independent recommended weight limit as well, which has some utility to it if you want to carve out frequency and just look at the other task variables, all other task variables other than frequency. The lifting index, as I said, is a risk index, which gives us an idea of the level of risk, or how much, if the actual load exceeds the recommended weight limit, how much so, and what's that ratio. So in this case, at the origin, the lifting index is below 1.0, and the risk index therefore is below 1, which is good. Gives us a green light. However, at the destination, we have a lifting index of 1.16. That's because the recommended weight limit for the task, based on the task variables that we input over here, the recommended weight limit is 21.48, and the actual weight exceeds that. I also want to mention that there's another calculator that we've developed for the WISHA, this WISHA lifting calculator. This methodology was developed by the Washington State Department of Labor and Industries. Again, it's an old tool, but has also stood the test of time. There aren't as many task variables to collect, so it tends to be a simpler, more easy to use, more user-friendly tool perhaps than the NIOSH lifting equation, because you don't have to consider all the other, many other task variables other than the vertical and horizontal locations, the frequency, duration, and whether or not there's twisting. So pretty simple inputs there. 6 inputs versus the NIOSH lifting equation, which would have 12 inputs or so. Don't quote me on that, but I think that's about right. 12 inputs, so 2 times the number of inputs in the NIOSH lifting equation. A little more complicated in terms of measuring for the NIOSH lifting equation, so some people like to simplify and utilize this tool. It's a validated tool in the public domain that is a great way to assess and screen lifting and lowering tasks that you think might be high risk. So this is the WISHA outputs, which gives us a weight limit, again, a recommended weight limit in NIOSH equation terms. and a lifting index, in this case of 1.57, which is well above 1 and indicates some risk is present for this task. Okay, that's a wrap for the introduction to the NIOSH lifting equation and the WISHA lifting calculator as well. If you would like to check the calculators out, feel free to go to our website. Go to ergo-plus.com, ergo-plus.com/platform, and there you will be able to create a free access account to all the calculators that we have, and we have additional calculators beyond the NIOSH and WISHA as well. So that's a wrap. Hope you have a great day, and we'll talk to you soon. Have a good one.